Hello guys, this is Ayan from FoodGenics. So we are back with the part 2 of GATE XCXL 2021 Food Tech Solutions. Hope you are excited. In case you didn't watch the first part of this solution series, kindly go back and have a look at it. The link is given in the description box. So we have covered a lot of ground. Let's see what we have next. So let's commence with the 11th question. So what is given is that there is a cold storage plant where 5000 kg of potato. So here we have the mass which is equal to 5000 kg, right? We have the mass 5000 kg of potato having a constant specific heat capacity of 3.65 kilojoule per kg per degree Celsius. Okay, so we have this value of Cp out here, Cp. Okay, then it is cooled from 28 degrees Celsius to 2 degrees Celsius in 24 hours. So here we have a delta T of 26 degrees Celsius. Okay, 26 degrees Celsius in 24 hours. Remember this, it is in 24 hours. Okay, now the heat of respiration of potato per 24 hour is 3.12 kilojoule. Okay, this is heat of respiration. Okay, per kg. Okay, per kg. So if we calculate the total heat of respiration, then it will be equal to your 5000 into 3.12 kilojoules. Okay, so the value comes out to be 15600 kilojoules, right? Now we will, as there is a temperature change, so we will have another heat. Okay, so which is equal to mcp delta T. Okay, mcp delta T. If we put the values out here, then we will get a value of 474,500 kilojoule, where m is your 5000 kg, then Cp is your 3.65. okay, this value, and delta T, you know, it is 26 degree. So these both heats are in 24 hours. Okay, 24 hours. Okay, now if I calculate the Q total, okay, if I calculate Q total, it is equal to your QR plus QY, Q1. Okay, so the value comes out to be your 490,100 kilojoule. Okay, now in the question they have asked in ton of refrigeration. So ton of refrigeration is linked with kilowatt. Okay, so if we have to convert this kilojoule into kilowatt, what we have to do is divide it by time. Okay, so how much time we have? We have 24 hours, right? So 24 hours. Okay, and if we convert it into seconds, then we have to multiply it with 3600, right? So this will become your kilowatt. Okay, the whole value will become kilowatt. So the value comes out to be 5.672453 kilowatt. Okay, so now they have given that the efficiency of the plant is 70%. Okay, so what we have to do is that we have to get a higher capacity of plant. That is, we have to, you know, like we have to divide it with 0.7. Okay, we have to divide the heat with 0.7. Okay, so Q required is equal to your 5 or you can say Q total by 0.7. Okay, and after converting it into kilowatt, okay, it is already in kilowatt, so after converting into in ton, we get a final answer of 2.304 ton. Okay, we get it answer of 2.304. So it is given that up to 2 decimal places, so we can write the answer as 2.30. This is our final answer. So the next question that we have is, which of the following combination of analytical equipment, property measured and food property are correct? Okay, so this is basically a MSQ type of question. Okay, that means multiple answers can be correct. Okay, so the first option that we have is particle size analyzer. So it is giving particle size distribution. This is perfectly correct. Okay, and property related to it is span value. Okay, so what basically a span value is, it is like a size where we have indication of how far the 10% and 90% points are apart, okay, from normalized with the midpoint. Okay, so we have something called this span. This span is equal to your D90 minus D10 by your D50. Okay, as I already said. So this is the correct option. Okay, now the second option that is given, differential scanning calorimeter. So this actually helps us to find the glass transition temperature. So what is basically the glass transition temperature? It is the temperature in which the solid substance start like giving property of glass. Okay, so it starts converting into glassy state. So the one of the major food property that it shows is the degree of caking. Okay, so when the the temperature gets above the glass transition temperature, it starts caking, and it shows the degree of caking. So it is also absolutely correct, option 2. Now the next option is your texture profile analyzer. Okay, so here what we have is that the texture profile analyzer is mainly shows us or give information about the texture and like some of the rheological properties. Okay, like chewiness. But this morphology is mainly about the structure. Okay, which is basically we find out using SEM, okay, or TEM, scanning electron microscope. So basically this texture profile analyzer and chewiness is a good match, but morphology is not the odd one here. So this is a wrong option. Now the last one that we have is your capillary viscometer. So yeah, this gives us information about viscosity, but to be it is very clear that there is no relation in like the viscosity and the sensory property. So this is also the incorrect option. So we have two correct here, that is option 1 and option 2. Now coming to the next question, again this is another MSQ. So here the question asks that which of the following compounds act as anti-nutritional factor. Okay, so the first option that we have is your resveratrol. So resveratrol is known to have high potential of your antioxidant property. Okay, so this can't be the anti-nutritional factor. So this is not our desired option. Next is trypsin inhibitor. So trypsin inhibitor mainly inhibits the activity of trypsin enzyme, which helps to digest protein. So yeah, this is one of the anti-nutritional factor mainly found in soybean. Okay, so this is our correct option. Next is your phytate. Okay, so phytate is another anti-nutritional factor, and the last option is isoflavones. So isoflavone is a bioactive compound which is also rich in antioxidant. So this can't be your anti-nutritional factor. Okay, and this phytate is mainly found in wheat. So this 2 and 3 is our correct option. So we have another NAT out here. So what is being asked in the question, dry air is fed into a tray dryer. Okay, so let us draw a tray dryer here. So this is dry air. Then the percentage relative humidity of air leaving the dryer is 60%. Okay, so this air is leaving the dryer, and the RH given, RH is your 60%. Okay, this is 60%. Next, at 70 degrees Celsius and 10135 kPa. Okay, so your temperature is given, which is your dry bulb temperature, T dBT, which is equal to your 70 degrees Celsius. and the total pressure is given as your 101. This is the value of P, total pressure. Okay. Now the next thing given is if saturated vapor pressure of water at 70 degrees Celsius is 31.2 kPa. So it is given that this one is your PAS. Okay, this one is your PAS, saturated vapor pressure. Now the humidity of the air leaving the dryer in kg water per kg dry air. Okay, so in the question we have been asked to calculate the humidity. So we know the formula for humidity is 0.622 Pa by P minus Pa. Okay, so P we know, right, 101.35, but we don't know the value of Pa, which is the partial pressure. So but we have the relative humidity. We know another relation, that is RH equal to Pa by PAS into 100%. Okay, we have this relation. So if we put the value of PAS out here and we know the RH here, so the Pa will be equal to 18.72 kilopascal. Okay, now if we directly put the value of Pa out here in this equation, okay, in this equation, the value of humidity that we are going to get is equal to 0.140915. Write the complete decimal. Okay, so this is our final answer. So they have asked to report it up to 3 decimal places. So up to 3 decimal places it will be 0.141. Okay, if we round off it, it will be 0.141. So the final answer will be 0.141. So moving to the next question. Okay, so it is given that in a typical bacterial growth curve, remember it is given growth curve. Okay, the first order kinetics for growth rate. Okay, first order kinetics for growth rate is observed. Okay, so let us see. This is a MCQ type of question. The first option is lag phase. Okay, so lag phase is the phase where we the microorganisms basically adjust to the environment. Okay, so here the growth doesn't takes place. Okay, so this is not the like they have asked about the growth rate, so this is obviously not the correct option. Next is your log phase. Okay, so yeah, the first order kinetics is applicable to your log phase. Okay, log phase. So this is how the microbial growth curve looks. This is your log phase, this is your stationary phase, and this is your death phase. Okay, so this death phase and this your this log phase and this death phase follows your first order kinetics, but in the question they have mentioned growth rate. Okay, so growth is mainly happening in your log phase, so that's why the correct answer is your log phase and not your death phase. So the correct option is option 2. So the next question that we have is that which of the following compounds is present in soybean and act as phytoestrogen? Okay, so first of all, what this phytoestrogen is, this is mainly the plant estrogen from plants. Okay, so this is actually a very straightforward question. So soybean contains this genistein compound, which is your the estrogen obtained from plants. Okay, then this second option is your tangeritin. So this is a polymethoxylated flavor. Okay, so this is mainly found in your tangerine and citrus peel. Okay, then the third option is your quercetin. Okay, quercetin is mainly found in your green tea and apple. Okay, then this lutein is also a pigment found in greeny leafy vegetables. Okay, so this is a very straightforward answer, which is your genistein. Moving towards the next question. So the next question that we have is the conversion of pyruvate to lactic acid in homolytic fermentation, it is catalyzed by. Okay, so if we write the reaction out here, so we can write it as pyruvate. Okay, pyruvate plus NaDH plus NaDH. Okay, so H plus ion is being added here, and as a result we get the lactic acid. Okay, we get lactic acid. Okay, so but this is mainly in presence of your lactate dehydrogenase. Okay, so what happens is that C double bond O is being reduced to your C single bond O. Okay, in presence of lactase dehydrogenase. So the answer is option 4. Now coming to the next question, this is from your milk product. Okay, so the question is ultra high temperature, that is UHT process of pasteurization of milk is achieved by heating it. So generally by pasteurization we know that the time temperature combination is your either 63 degrees Celsius for 30 minutes, okay, for 30 minutes, or your 72 degrees Celsius for 15 seconds, okay, for 15 seconds. But in this is the normal pasteurization condition in which we have to keep the milk in a refrigerated condition. But if we want the sterilization and want to keep it in ambient condition, then we go to the UHT process, and the standard time temperature for that UHT process is your 280 degree Fahrenheit for 2 seconds. It is done for a very short time, that is your 2 seconds. Okay, so the correct answer is your option 4. So the next question is again a native type question. So what is given? Orange juice sample is concentrated from 10% to 40% by weight total soluble solids in a single effect evaporator. Okay, so let us draw the block diagram. Okay, so this is your feed. It is given that 10% TSS. Okay, 10% TSS. Okay, and it is at 25 degrees Celsius. The feed is at 25 degree Celsius. Okay, and the feed rate of 3600 kg per hour. So it is in per hour. So if we convert, at the end, like I can see here the unit is in kilowatt. So let us move convert it into SI. So if we convert it into seconds, so it will become the flow rate will become 1 kg per second. Okay, and we are getting a product of 40% TSS. Okay, so here in the product the TSS is your 40%. Okay, and the vapor is evaporating. So if we have to find out that what is the amount of your feed and product and vapor, so if we do the simple material balance, so F is equal to V plus P. Now if we do the solid balance, so vapor doesn't have any solids, so 10%, that is your 0.1 F is equal to your 0.4 P. So from here F is your 1 kg per second, so P is equal to your 0.25 kg per second. That means if we put the value of P out here in this equation, and P is 0.25 and F is 1, so V we will get is equal to 0.75. Okay, 75 kg per second. So this is the basic the materials that is going in and coming out. Okay, now what the question is demanding, so they are asking for the heat transfer rate through the heating surface area of evaporator in kilowatt. Okay, so heat transfer rate, so heat is what will be the main heat out here, so that the inlet temperature is 25 degrees Celsius and the product temperature is your 55 degrees Celsius, and vapors are also evaporating at 55 degree Celsius. Okay, so the first task out here will be to take the feed to your 55 degrees Celsius. So the heat involved for that is equal to Q sensible, we call it as sensible heat, Q sensible, which is equal to how much? mCp delta T, mCp delta T. Okay, your m is equal to your 1 here, okay, because the whole feed we need to take to 55 degrees Celsius. So mCp delta T, Cp is how much? Cp is your 4 kilojoule per kg per degree Celsius, okay, and delta T is 25 from 25 to 55, that is your 30, okay, that is your 30, which is equal to your 120 kilojoule. Now this is not the end. We can see that certain amount of vapor is also forming, okay. So here we have the this one, the enthalpy of water vapor at 55 degrees Celsius, okay. So now the heat involved is in that is your latent heat, that is equal to ml. So the m is given or we have calculated at 0.75, and L is your 2600. L is your 2600 kilojoule, okay, per second. So the total amount of heat by adding both of them is equal to your 2070 kilojoule per second, which is equal to 2070 kilowatt. So the next question is, which of the following statement is incorrect, okay. So please note this, we have to mark the incorrect one, okay, with respect to cap and map, okay, of agro produce. So the first option is gas composition inside a map during the storage is continuously monitored and regulated, okay. So in map what we do is at the initial when we start the packaging, at that position we modify the atmosphere inside it, but after that we do not monitor or regulate it, rather it is done in case of cap, okay. So this is actually an incorrect option, okay. So this is correct as per the question, okay. Next, if we see although this is MCQ, still let us verify. So the next option is cap implies a greater degree of precision than map in maintaining specific levels of the gas composition. Yeah, in the option 1 only I mentioned this, that in cap we generally monitor and regulate it, okay. So yeah, this option is correct. Then in the third option we have modification of atmosphere inside a map is achieved by natural interplay between respiration of product and permeation of gases through the packaging. Yes, we don't alter the gases, rather it is the alteration is done inside the package, which is quite natural, okay. So this is also an correct option. Then the fourth one, that is cap and map limit microbial as well as biochemical activities. Yeah, these are the modern techniques to inhibit the growth of microorganisms, and also to reduce the biochemical activities. So this is also an correct option. So the only incorrect option is your option 1, which is our desirable answer, okay. So moving to the next question, we have a match type question out here. So let us see how we can approach this, okay. So we know that blanching is a very common process where inactivation of enzyme takes place, okay, in blanching. So this Q is the third, Q is Q3. So only we have Q3 in option 2. So this is a very straightforward match. Still let us verify the other options. Then this is winterization. Winterization is in the oil seed processing. In refining we have one stage, that is winterization, which is mainly for the removal of wax. So S is equal to relating to 1. So S1. Then blanching Q3. Then hydrogenation is mainly hydrogenation mainly helps in the solidifying the fat. So shortening is the higher solidified fat. So this is relating P is relating to your 2. So P2, and leaching is mainly use unit operation for separation of dye. So R4. So all the option in option 2, all the like given options are matching. So the correct option is your option 2. So moving to our final question of this food technology. So it is given, which of the following is or are correct pair of grass that is generally regarded as safe, chemical food preservative, affected organisms and given food matrix. So this is an MSQ, okay. So sodium nitrate basically used as an curing agent in meat product, okay, which suppresses the growth of Clostridium botulinum. So this option 1 is absolutely correct, okay. Now coming to option 2, sodium lactate is used in pre-cooked meat in order to prevent the growth of pathogenic bacteria, okay. So this is also a correct option, okay. Now this third one, that is dihydroacetic acid, okay, this is used in squash, okay, this is used in squash, okay, but to prevent the insect, not molds, okay, it is to prevent the insect. So this is a wrong option. Then the last one, caprylic acid, it is used in cheese wrap but to prevent molds, not insects. Hope you guys have enjoyed this video. With this, we conclude our XC Food Technology paper solutions. Stay tuned for the third part of this video series where we are going to release the life sciences solutions for you. Please like, share and subscribe to our channel. Press the bell icon for future notifications.